In this video, I will go through part 2 of section 1.2 of chapter 2 of FS1. Okay, here are two examples, example 2 and example 3. X follows the Poisson distribution. Find probability of X less than or equal to 3. Okay, to find probability of X less than or equal to 3, if we use the method from the previous lesson, we should find probability of X equal to 0, X equal to 1, 2, and 3. Add them up to find probability of X less than or equal to 0. However, we don't need to do all of this calculation. All we could do is using the table, which is the Poisson cumulative distribution table. Meaning, if we use, okay, we know that in this specific example, lambda is equal to 5 and X is less than or equal to 3. So all we need to do, just find lambda equals to 5, which is here. So I just zoom it a little bit. Okay, yep. Lambda is equals to 5 and X equal to less than or equal to 3, which would be this value, 0.2650. Okay, so first of all, Poisson cumulative distribution function, what does it mean? It means if we find for 3 and lambda equal X equal to 3 and lambda equal to 5, this value is the value for less than or equal to 3. It means it's been X equal to 0, 1, 2, and 3 been added and it became 0.2650. Okay, so all these values are for less than or equal to. For example, if it was X less than or equal to 15, rather than finding probability of X equal to 0, 1, 2, up to 15, all we need to do, just find the lambda from here and match with the X value here, which is 15. Okay, so in our specific example, we've got lambda equals to 5 and X less than or equal to 3, which is 0.2650. Okay, so let's go back to our example again. Okay, 0.2650. However, we can use calculator for this answer. Okay, so all we need to do is just set up number 7. Okay, so move to the next slide, which is Poisson. Okay, PD or CD. PD is just for a specific value. If it was X equal to, for example, 2 or X equal to 3. CD is for cumulative distribution. It means when X is less than or equal to 3, it calculates all the way up to 3. X equal to 0, 1, 2, and 3. Add them up and it gives you the final value. Okay, this is number 2 variable. Okay, so X is equal to 3 in this case, X equal to 3 and lambda is equals to 5. So we can clearly see that it is 0.2650 and so on. So now it's up to you whether to use calculator or the table. However, you are allowed to use calculator in the exam. I would strongly advise to learn how to use calculator just to avoid extra working in the exam. So probability of X greater or equal to 2. Okay, greater or equal to 2. If I draw a number line, okay, so let's say here is 0, 1, 2, 3, 4. It continues forever. Okay, so greater or equal to 2. So all the values, since it is discrete variable, so it takes only the whole numbers, all of these values. But we know that the total probability, okay, it would be obviously really difficult to calculate all the values greater or equal to 2. But what we could do, we know the total probability for this is 1. If I take away the probability of 1 and 2, okay, then minus probability of x less than or equal to 1. Less than or equal to 1 means 1 and 0. Okay, it will be equivalent to probability of x greater or equal to 2. Okay, so therefore 1 minus probability of x less than or equal to 1. Okay, 1 minus. However, I could use calculator again, or less than or equal to 1 and then sub it there. So it would be x is 1, lambda is 5, and we get 0.040427 and so on. So 0.040442 and continues. So, however, definitely save this solution in your calculator and take away the exact value of this from 1 rather than the rounded value. Okay, and then round it up right at the end. If you do that, then you should get 0.9596. Okay, next example is probability of x between 4 and 1. Okay, again, I would draw the number line. Let's say here is 0, 1, 2, 3, 4. Okay, between 1 and 4, it means probability of x equal to 1 plus x equal to 2 plus x equal to 3 and finally plus x equal to 4. But rather than doing that, I know that I can easily calculate probability of x less than or equal to 4 using either my calculator or the table. Okay, so all I want is 4, 3, 2, 1. 1 and 4 are inclusive, so therefore I need 1 and 4. What I don't need here is only 0. My calculator can calculate up to probability of x less than or equal to 0, x less than or equal to 4. Okay, so if I do that, equal to probability of x less than or equal to 4. All I need just to take away 0 from here. Probability of x equal to 0. Okay, then it will give me probability of x between 1 and 4. Okay, so let's calculate less than or equal to 4. 4 and lambda is the same lambda because it's the same question. Okay, which is 0.440449 and so on. Save the answer and then let's use the Poisson PD for x equal to 0. Okay, so because we want to calculate for exactly one value. So number 2, it is variable again. Don't worry about the list for now. X equal to 0 and lambda equals to 5, which we get 6.73 times by 10 to the power of minus 3. Okay. So, or 0.0067 and so on. Okay, just taking away this from this one, we get 0.4338. These are almost all the possibilities which we can get in the exam. Okay, to calculate the probability of x less than or equal to, greater or equal to, x between 1 and 4, both are inclusive. And so, example 3. X follows the Poisson distribution with lambda of 7.5. Okay, find A, B, and C. Okay, so I have to complete this one first. Probability of x less than or equal to is given, which is given 0.2414. Okay, in this case the probability is given and we are required to work out this value of A. Okay, so we can do exactly the same thing as previous questions. It's just the opposite of that. So we've got lambda equal to 7.5. Okay, so let's use the table first and then I'll show you how to use the calculator for this as well. Lambda is equal to 7.5. Okay, and the probability is given. The probability is 0.2414 up to 4 decimal places. 7.1, 0.2414. If you join it to the x, you will get equals to 5. So basically these probabilities are given, lambda is given, and all you need, just join it to the value of x and see for what value of x probability is 0.2414 with lambda of 7.5. In this case, we can clearly see 7.5, join it to the probability and then join it to the x, which is x equals to 5. Or in this case, A equals to 5. However, you can use calculator again. Okay, but in this case, so what we need to do, we have to insert the x values by trial and error method. Let's say I enter 3. I know the lambda, which is 7.5. Okay, let's see what do I get for the probability. I get 0.038, which is way smaller than 0.2414. So what do I need to do? I need to change x now. Let's say for 4. Okay, so what do I get? 0.07. So it's increasing, getting closer to this. But it's not this one. Let's try 5. Okay, not point. So I have to go to CD. I think I have clicked on PD. Okay, so Python CD number 3 list or variables. Okay, now yes. So let's try 3. What do I get is 0.05, which is smaller than 0.241. Okay, let's try 4, which is 0.13. It's getting closer to 0.24. So therefore, let's move on for one higher, 5. We see it is 0.2414. Okay. So the next example is probability, given that probability of x less than b is equal to 0.525. 4, 6. I draw a number line again. Let's say here is B. Okay. We don't know what are these numbers. If, for example, B is 7, this number would be 6. This number would be 5, and so on. Less than B. B is exclusive, so therefore we are not looking for this probability is not given for B. It is given for B minus 1. In fact, probability of x less than or equal to B minus 1 is equal to 0.5246. Meaning, any value I find for this, I have to take away 1 from that. Okay, so let's see what's the value. So we already worked out up to 5 for the same lambda, 7.5, which was 0.2414. Okay, let's try it for, let's say, obviously it is way bigger than this. Let's say 7, or let's try 6 first. Okay, what do we get? 0.37, which is not equal to this. Or you could use obviously the table, okay, from the FS1 textbook. Okay, and let's try 7. What do we get? 0.5246. Okay, so therefore we worked out B minus 1 because our calculator, it calculates up to less than or equal. So therefore B minus 1 is equal to, we insert 7. Okay, so therefore adding 1 to both sides, we should get B equals to 8. Therefore B minus 1 is 7, and finally B is equals to 8. Okay, the next one is probability of x greater or equal to C. However, both our calculator and the table doesn't give any value for greater or equal to. It always gives less than or equal to. Let's say here is C. Greater or equal to C would be all these values. So equal to C as well. Okay, and so on. So we don't really need these values then. Okay, so it is already given that. I forgot to write it here. First, 0.3380. This is given. Okay, so all of these probabilities is 0.3380. Okay, therefore, we could say all of these probabilities, the full probability is 1. Okay, so I could say 1 minus probability of x less than or equal to. Obviously, the calculator shows the equal to, up to equal to, not only less than. Okay, all of this minus this bit gives us all of this. What is this bit? Less than or equal to, this is C. Obviously, this one should be C minus 1. C minus 1 equals to 0.3380. So you can take probability of x less than or equal to C minus 1 to right hand side and 0.3380 to left hand side. What do you get? You get probability of x less than or equal to C minus 1 is equal to 1 minus 0.3380. Okay, and I just keep writing here probability of x less than or equal to c minus 1 is equal to 0.6620. Okay, now let's try using the calculator. So lambda is equal to 7.5, which we already got. Let's say we already calculated for x equal to 7, which was smaller than this number. Let's try for x equals to 8 now. What do we get? 0.6619. So 196. So it runs to 0.6620. Therefore, c minus 1 is equal to 8. And finally, c is equals to 9. However, you could use calculate the table for this as well. Okay, end of this section, and you should be able to do the exercise 2b from chapter 2 of FS1.